Alright, we're going to do some dy problems for volume using disk and washer method. So far we've done the dx problems where we have a horizontal revolution, but now we're going to look at some that have a vertical revolution. So we're going to take the region bounded by y equals x cubed, y equals 0, x equals 2, about the line x equals 2. Now let's graph it first. So y equals x cubed is going to look like this. Y equals 0 is our x-axis, and x equals 2 is this line right here. Alright, so the region that we have bounded is this region right here. Now we're going to spin this around the line x equals 2. Well, when you do this, you see how there's no space between the region bounded and the axis of revolution. So it's going to make these solid circles here. Okay, and whenever you have those solid circles, that if you were to slice this, we're going to use the disk method. Now remember, the disk method is volume equals pi, integral from a to b, r squared, and in this case we're going to do dy since it's a vertical revolution. Well, since we're dealing with dy, everything has to be in terms of y. That means your limits have to be in terms of y, and your r has to be in terms of y. So let's start off with the limits. We usually, in the dx problems, looked on the x-axis. Well, now we're going to look on the y-axis. So our shaded region goes from 0 to this value here. Well, we can find that value by taking the 2 and plugging it into x cubed, and we get 8. So our limit's going to be 0 to 8. Now, we need to find r. Now r, we start on that axis of revolution, go across through the shading, and for this one we're going to do right minus left. So r in this case is going to be 2 minus, now remember we have to do it in terms of y. Right now our function is in terms of x. But if we solve this for x equals cube root of y. So this line here is actually the cube root of y in this case. So we're going to do 2 minus cube root of y. And that's going to be our r value. So we're going to plug that in here for r, 2 minus cube root of y squared dy, and that's going to be our setup for this problem. Now we're not going to evaluate it today, but in order to evaluate it, we would go ahead and FOIL it out and then integrate. Let's go ahead and try a different problem. So this was the disk method. We're going to change the line that we rotate this about to the y-axis. We're going to leave everything else the same, but now we're going to do about the y-axis. So let's go ahead and graph it real quick again. We have our x cubed, x equals 2, and of course our x-axis. Here's a region that we have shaded, and this time we're going to take it around the y-axis. And if you look at this, when we spin this around, we get this goblet-looking shape inside. But notice that it's all empty inside. There's all this space in between the shaded region and the axis of revolution, which is the y-axis. Whenever you have that space, we're going to use washer. And remember, washer is volume equals pi, a to b, big R squared minus little r squared. And again, we're going to do dy because it's a vertical revolution. So our limits haven't changed. It's still shaded from 0 to 8. So we can just go ahead and put in 0 to 8 for that. But what we need to find out is what is our big R and our little r. Now, in order to find that big R and little r, again, we start on that axis of revolution and go over through the shading until you get to the end of the shading. That's going to be our big R. So we do right minus left again. So in this case, 2 minus 0, which is just 2. For our little r, we're going to do the same thing. We're going to start on the axis of revolution, but we're going to go over until we hit the first line. When you hit that first line, that's your little r. And in this case, right minus left again, remember we got to keep it in terms of y. So that's going to be cube root of y minus 0, which is just cube root of y. So we're going to take that big R, put it in, 2 squared minus the little r cube root of y squared dy, and this would be our setup for this. and then we'd go ahead and evaluate. All our dy problems are very similar to this. Okay, everything has to be in terms of y, and we just got to make sure that our limits are in terms of y, our r's are in terms of y, and of course we have dy at the end. All right, this is for a vertical revolution. With our horizontal revolutions, we would just do it normally with terms of x.